guys, today we're going to look at scatter plots in line of best fit. A scatter plot shows a relationship between two variables. So we've got positive, negative, and no correlation or none. So we've got positive if the scatter plot, the dots are increasing. Negative correlation if the dots, when graphed, show that they're decreasing. And then negative correlation or no correlation or none, no correlation or none is the dots are all over the place. Okay, so using that information, we're going to construct a scatter plot. So if we connect the dots, 1.1 and 0.23 would be about here. Okay, 1.1, 0.23, same spot, 2.7, and then 0.48 would be about here. 4 and 0.63 would be about here. 4.1 and 6.8, just a little bit higher than that. 5 and 0.74 would be somewhere in there. 5.1 and 7.6 we'll say is there. And then we have 6.5 and 0.84 somewhere in there. And then 9.1 and 0.86 we'll say is about there. And then 9.6 and 0.85 would be about here. Okay, so looking at your dots, they are increasing. So this would be a positive correlation. Okay, next one. $1 and 13 million. I'm gonna put the commas in. Okay, so 1 and 13 million or so would be up in here. And then 2 and 12 million would be somewhere in here. And then 6 and 6 million somewhere in there. Oops, that should almost be 700 or 7 million right there. Then we got 10 and a little over 4 million. And then 14 and a little over 2 million would be about here. 30 and less than 200,000 would be way down here. Okay, then we got 71 and 1,280 would be way down here. And then 83 and 270, and then 97, and then 85 and 210, again, way down here. Okay, so looking at the dots, I could almost draw a line and it would look like this. Hopefully your line would be a little straighter than mine. But this would be a negative correlation. Okay, to speed this along, I'm going to just put the next one on the board and explain it, because hopefully you know how to graph. So this one, dots are all over the place. You can draw a line to go with the graph. So that's a no correlation. Okay, next thing we're going to look at is line of best fit. So I'm going to give you the line of best fit. We're going to talk about what the slope represents. So for the number of marriage licenses issued by Clark County, Nevada, the county where Las Vegas is located, has been decreasing since the year 2000. This can be modeled by y equals negative 3,199.2x plus 6,540,600, where x is the year and y is the number of marriage licenses issued. What does the slope of the line represent? Okay, so x is the year and negative 3,199.2 represents how it's decreasing each year. So remember, slope is the change. So we're always going to start with saying the slope is the change. It's the change, and x represents, this whole function represents marriage license. So it's the change in number of marriage licenses issued each year. So since x represents the year, that's where I come up with it's decreasing each year. And the overall, the function, y, is the number of marriage licenses issued. Okay, part B. According to the model, how many marriage licenses were issued in 2006? Round your answer to the nearest hundred. So pay attention to that. We're going to use this formula. And notice x is the year. Well, they give us the year is 2006. So I plug 2006 in for x. Okay, and I get this number, but don't just put this number because it says round to the nearest hundredth. Well, the 4 tells us the nearest hundredth would be this. Okay, so I would have either rounded up to 123,000, or rounded down to 123,000, or rounded up to 124,000. Since this is just 4, that's less than 50, we round down. Okay, so make sure you're following the directions. Okay, let's look at another example. Scientists have steadily increased the amount of grain that farmers can produce each year. The yield for farms in China is given by y equals 100x minus 195,000, where x is the year, okay, x is the year, and y is the grain yield. So remember, slope always represents the change, okay? So what does the slope of the line represent? We can say the change, in this case it's an increase, okay? So the change or increase, and ask yourself, what does y represent? Okay, y represents the crop yield. Then we tie in what X is the year, so each year. Okay, next, according to the model, what was the crop yield in 1995? Round your answer to the nearest whole number. So we take our equation and plug in 1995. And luckily, this comes out to a whole number. So it's 4,500 kilograms per HA. And I got that label from right here. That's the crop yield. Okay, we got one more example. Okay, the cost of a flight is related to the length of the flight by y equals 0.149x plus 27, where x is the distance in kilometers and y is the cost in dollars. Okay, so x is the distance. We're talking about the cost. So the slope represents the additional cost for each, and how are you getting charged? You're getting charged by the kilometer. So that's what you say. The additional cost for each additional kilometer. So since the equation is about cost, the slope has to be related to the cost. And you're getting charged by the kilometer, so you got to include that. Okay, last question. Using this model, what would the cost of a flight that travels 2,650 kilometers be? Round your answer to the nearest dollar. Okay, so what have we been doing the whole time? X is kilometers. So this is X. And we plug it in. So round to the nearest dollar. So I get $421.85. That's not rounded to the nearest dollar. 85 cents is over 50, so we round it up to $422. Okay, that's line of best fit.